So now that I have my weighted parametric grid, I can now start looking at transformations. And this is going to be an iterative process, so we're not trying to get the exact diagram the first time. We're basically going to run through a lot of options and several versions of those options before we find the one that is the most serviceable, let's say. There's no such thing as a right diagram or a wrong diagram, but there's some that are more interesting than others. And we'll talk a little bit more about that after we try this. So I'm going to start looking at just one element. You want to be as reductive as possible and take a thin slice of the data that you see in the plan. So I'm going to look at these thick wall segments here. So I see one here, there, and a few before. And the only rule is that you're not allowed to fill in or poche the grid quadrants that we're looking at. So when I say grid quadrants, I mean a grid quadrant would be anything that is bound by 4 lines of the grid. So that is a quadrant. The space between those 4 lines. So let's look at those thick walls, and let's start by transforming them and come up with the simplest rule we can that has the most magnitude, meaning that extends the furthest, because we want to be able to fill up the page with figure. So let's try a rule that just says we're going to run perpendicular from those until they hit another pochette item. And when we get into it, we can talk about what we're going to do with overlaps. So tape this down, make sure it goes at least over your 8.5 by 11 page. We can do these freehand. I'm going to be using a black felt tip pen just so we can see it, but we don't have to be too precious about this because we're going to do several versions. Now with my reference copy in front of me, I'm going to poche just from those thick walls, and I'm going to go in the perpendicular direction from those. So I'm starting with the lines that will bound that solid, and then I will fill that in. The lines will no longer exist when we do this, and I'm not being too careful about filling it in, but I do want to be able to read figure versus ground, so I want it to be relatively dark. And this first round will be a little bit rough, but they'll get more sophisticated as we go, or as we do more refined versions. So here, I'm faced with a situation where I have this guy projecting this way and this wall projecting this way. So for now I'm going to leave that portion blank because that has an overlap of 2 to it. I am going to stop this projection at these walls, but I'm going to let it run through that window because I said I'm going to project to infinity or until it hits a wall. So I'm going to let it go through that window. So again, this is the projection of this wall here. So this portion I can fill in. So what do we do with this area here where we have the overlap of 2? So you could say that if you have 2 overlaps, they just turn white. which is acceptable, but maybe you want to hold on to more information there. So I'll make a sub-rule that says that if two of these projections overlap, then you come in, say, 2 quadrants, so 1, 2 from each edge. So that would be basically to there and to here, and 1, 2 to there. And you leave that inner portion, well, or maybe that's the portion that's pochade. So you acknowledge that there's a different thing happening there. And there's no right or wrong way to make those kind of judgments about exceptions to the rule, but obviously they have different results. So that's one. Obviously ignore this. In the final version, this will go away. So you know what? Just for expediency on this, we can come in and see what that's going to look like. So how do we know if a figure ground drawing is interesting or not? I think there's probably 3 criteria. The first would be figure ground reversal, or activation of the negative space. So we've all seen this vase silhouette exercise. When the negative space becomes the figure of the vase or the candlestick, instead of seeing the 2 faces, that's figure ground reversal. Also, dynamic interaction of form. So that would be if you have a figure or figures that seem to be having an influence on one another. Such as this, where things are slipping into one another and seem to be pushing at one another. That's dynamic interaction of form. And the last, I would say, is hierarchy, which is really just another word for difference. So that could be not just big and small things, but thin and thick, complex shapes versus simple shapes. That can come in a lot of different forms, but it's essentially the opposite of sameness. So if you have a field of all squares, you don't have a lot of hierarchy. So does this figure ground have the things that we consider interesting? Let's see, figure ground reversal, maybe a little bit in this figure captured in the center, maybe a little bit there, but not very strong. Dynamic interaction of form, not so much, because we don't really have any of these kind of pushing into one another. There's maybe some kind of implication of influence across here, but not yet. Hierarchy or difference, not too much. There's some differentiated shapes versus regular shapes, but they're all about the same thickness or density. So I don't know that this would be interesting yet, but it might be more interesting if we added another direction, or we can just look at another way to look at walls. So this time I'm going to poche all quadrants parallel with the wall, parallel and in line with the wall, to infinity. So let's start. I'm not really going to pay attention to anything else but where there is a thick wall and where there is not. So these are easy. Project these to the outside. Here though, between those two thick walls, how do I deal with that? Because I would have a projection from the end of this wall and a projection from this wall over, so those are going to overlap. So for now, I'm going to do a little bit what I did with the first one and just make a little note that that's a 2, or an overlap of 2. I can come back to that later. So what do we do with these two that are essentially between two areas between two thicker walls, so they're different than the other ones? Well, we want to try to hold on to that difference. I'm not sure I want to project that all the way across because then I get another overlap. So maybe I make a rule, and this is always just you posit something, take a guess, and then try it out and see how it looks. So I think what I'll do is I'll make a rule that when two of these projections overlap, then I'm going to fillet those, or basically poche the adjacent quadrants, the number of quadrants perpendicular that cross this. So I'm going to say 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13. So let me go out 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 13. And poche this portion, and this 13 quadrants will take us off the page. And let's see, 1, 2, 3, 7, 8, 9, 10, 11, 12, 13. Curious. And again, that will take us off the page. So, is this interesting as a figure ground? Sometimes it helps to lift it off so you can see its own attributes. Well, figure ground reversal, not too much. Maybe there's a little bit of a hint, something coming through here, but not so much. Dynamic interaction of form, there's a little bit of an implication that that gap kind of runs through there and creates a little bit of a ghost one, so maybe a little bit. Hierarchy, yeah, we've got some pretty good hierarchy. These are obviously thicker and kind of a different configuration than these things. It is possible later, after you've done several of these, to look at them on top of one another and see if combining them might make an interesting diagram. But at first we just want to see if we can make one diagram with one rule, or one rule and a very simple rule and a couple of small subsets like the projection rule that we had for the overlaps. Okay, so we want you to do multiple ideas or look at multiple families of things in the plan, and then do multiple iterations of each idea. And I'll be doing more demos just to kind of show you other sets of data. Good luck.